that one says interaction design, but yeah, I did for occupational therapy. And this is where we go through and design a serious game for health. We haven't done that workshop with these guys. Maybe I should. And on the back, the opening presentation I gave you guys was I showed you the kind of 5 agency and feedback and experimentation, social interactions, and curiosity. You remember those kind of more engaging aspects? And the lecturer in occupational therapy said that's actually very similar to the models they use for dealing with how you design a therapy for an individual. So and very much occupational therapy is about agency, right? It's about giving people back control over their lives. Usually they've had an accident or they've got something broken or wrong, and so the occupational therapist comes in and tries to give them back actions and power and empower the patient. So it was interesting to have her say that that's actually very similar to their model. They don't really have so much curiosity, but they certainly do have agency, feedback, experimentation, and social interactions. So it was interesting getting the occupational therapist to try and design a game. Given that most of them don't play games, I think I asked and 2 of them played games. And I asked how many of them had played Minecraft, and not one of them had played Minecraft.
They didn't know what it was.
Did they know what it was?
They'd heard of it,
Okay.
right? But none of them had ever played Minecraft. Which, you know, when I asked in 3 or 4 years' time, I'm going to be starting the wave of kids who have played Minecraft, and it'll be eventually 100%, because every 12-year-old I ask has played Minecraft.
New Windows doesn't have Minecraft anymore.
But Windows
Or at
doesn't
least I'm too stupid to find it.
not Minesweeper. You're thinking Minesweeper.
Minesweeper, yes,
Yes.
Minecraft.
Yeah, I'm thinking Minecraft. Much more complex.
I remember what that is too. Yes.
Okay.
You can install it. It's not with the system. Yes.
No, it's not with the system.
Yes.
So Minesweeper was a time sink. A lot of people spend a lot of time doing Minesweeper. So yeah, so it was interesting to get that kind of to see what the occupational therapy people thought of that model and how they used it. Also, because we talked about the 6 animal model with you guys a little bit, I mentioned it. Okay, we'll go through that as well, just as a way of working in groups. I'm thinking of doing that with the entrepreneurship course, and we had 25 people in the class, and about 12 of them identified as cats in my model. And the cats are the cynics who try to find the ways around doing things without the minimal effort. And so nearly half the class identified themselves as being cynics who try and find a way out of doing stuff. So I had to turn some of the cats into bears and wolves and owls and stuff to get work done. So we'll discuss that on Friday, because you guys are mostly in the digital entrepreneurship course.
Are you teaching that one too?
No, I'm involved. But Stein, how do I don't know.
Laos?
Laos is how you say it? Because double L, which of course immediately makes me think Welsh, which would be cl.
Okay.
Right? So Llanelli is double L as starting. So so my mind immediately goes Welsh when I see double L's. So yeah, so we'll discuss like personality types and working groups. Okay, so today we have 2 papers to discuss. And did any of you read the very short thing from Ian Bogost?
I've read.
Yep.
Also the framework.
That was basically gamification is bullshit.
Oh, that one. Yeah, I didn't.
Okay, so
From a philosophical point of view.
from a philosophical point of view, I've also been because there's a new book in which he's.
I like the definition.
Yeah, I like it.
And formality to approach the topic.
Yes, he treats bullshit in
Define bullshit.
as a definable philosophical position that you have, and given his choice of definition of bullshit, then yes.
It was consistent.
So yes.
But I would say it wasn't that far from the mark when it comes to how he argued that it was bullshit.
I would say that there is a type of gamification, which is entirely bullshit, right? It's like statistics, right? When you say statistics is used to lie, well, yes, statistics are lies. Maybe all statistics are lies. Not
No.
really. But yeah, so I think that some statistics are used for lying. Definitely true. Some gamification is complete bullshit. Absolutely 100% agree. All gamification is bullshit. All statistics are lies. I'm not on board with the generalization, but I said it. Well,
But for a position paper, you need to make a strong position.
and then he so there's been a recent chapter in a book which we haven't got yet because they haven't started shipping it anyway. But Google has sample pages, so I was scanning some of the sample pages on Google from the book with Ian Bogost, who's basically expanding that argument to a full book chapter.
That is.
So yeah. So he's got a whole book chapter now on why gamification is bullshit. And he does do some interesting things, like he talks about someone who was talking about a clever way of learning Vim, right? So like a game for learning Vim as the Vi editor, right? And it's not commercial in any possible way, right? And he did the policing English language usage is a false error, right? Which is true, right? Because basically he said, well, that person's not using gamification in the way I'm defining gamification, right? And we get into an issue of the no true Scotsman fallacy. You guys know the no true Scotsman fallacy? Okay. So all true Scotsmen wear kilts. How do you disprove that? All true Scotsmen wear kilts. How would you disprove that statement?
Find a single Scotsman who is not wearing a kilt.
Right. And my response is, well, he's not a true Scotsman. So, how do you find a counterexample?
Find another one. No.
Find another Scotsman. If he doesn't wear a coat, he's not a true Scotsman. So the definition itself incorporates saying true Scotsman, incorporates the feature that I'm saying all true Scotsmen have. I'm actually using as the definition of true Scotsman.
But the missing point in that argument is that is it wearing it all the time, or is it just wearing it kilt at some point in time?
If he's a true Scotsman, he wears it all the time. So I can define a very, very small group of people.
Yeah,
So-
but then you have to redefine the argument you first made, which means that you are admitting
No,
that the first was
No, I'm not redefining. I've just said all true Scotsmen wear kilts. And because you cannot find someone I will accept as a true Scotsman who doesn't wear a kilt, you can't disprove my argument.
Per definition, this is right.
Per definition, the no true Scotsman fallacy, right? And I think this is getting close to that. Is I'm defining gamification in a way that all gamification is bullshit. Find me a gamification that isn't bullshit, and I'll go, well, actually, that's not really the usage that I meant of gamification. Boy, yeah, well, of course you're right, because you're only talking about this small group of gamification, because you've defined it as bullshit, and then saying gamification is bullshit. Because so
what it says is that gamification that's used to conceal, to impress, or coerce is per definition bullshit. So all other use of gamification, that's not gamification, that's fine.
yeah, but he would say most so it was
Conceal, impress, or coerce.
Yeah. So conceal, impress, or coerce. Depending on how you define those words, you could consider training a form of coercion. Right? And personally, education a form of impressing people. Right? So it depends on how loose you get with the terms. But I think if you define gamification down to just those three, well, you could say anything that just does those three is bullshit.
That's what they say.
Basically, yeah. So per definition. So yeah, but it is useful to have contrarians, people who hold a different position to you, and decide whether or not their argument is valid. and whether or not their conclusion is valid, right? Because those two things are independent. So, for example, in the two papers we've got here, like the discussion on the Kai paper on is like, yeah, what does gamification of community science do? You could completely agree with the conclusions about the effects of using gamifications in citizen science, but still be very critical of their method of getting to that discussion. Right? It's harder the other way. It's hard to completely agree with someone's argument argument process and then disagree with their conclusion. Right? Usually what you have to do then is disagree with one of the axioms that they're holding as true. Right? So for example, I do this regularly with religion. Right? If you hold the axiom that God exists, then you can make a whole bunch of very logical, very consistent arguments that lead to specific conclusions and behaviors you should follow. Okay? And I cannot fault the logic of those arguments because they're entirely correct. I disagree with one of the axioms, which they're holding as true without providing justification for. Right? The existence of God, or the existence of aliens that deposited mankind into volcanoes, or whatever that Scientology shit is about. Do you guys understand Scientology?
I didn't fall for the episode.
I think that's it. And you understand the creation of Scientology? That L. Ron Hubbard wrote an article.
Okay.
Wrote an article saying that the easiest way to make money was to create a religion.
I understand that.
And then 5 years later, he created a religion and made a lot of money.
So basically, he did a research experiment that went horribly wrong.
No, it went well.
In Bogost did the same thing with an app called Cow Clicker, right? He made a satirical cow clicking Facebook app, I think.
Yeah.
So he made it as a satirical attack on all of these click-fest games and made hundreds of thousands of dollars because it became so popular and he got so much ad revenue. He was trying to make a social comment and made a lot of money from it. Which, is that then a failed social? I'm not sure, but yeah. So so he actually did make quite a lot of money on his satirical cow clicking app. Okay, so today, so we have your present. No, who is it? Ah, there. Sorry. Right. Okay, so do you want me to go first with the slightly more formal article, and I'll go to the Kai article. Now, normally, if you guys see Kai, it's normally considered quite a good paper. What do you guys think of this one? Of the Kai paper? Any more impressions of this Kai paper? Did you read it? No, I was just asking the general question on this one on citizen science and engagement. I don't want to apply the article. Reload the page. I have actually got it there. I should go to the front page and go to that.
That's the one where they interviewed like 8 people.
Yeah.
Yeah. The mean age was 47.5 years, so that's very old.
Yeah.
Kind of old.
Yeah, I think you could perhaps think that it always does that. I hate when you start editing something because you've got the editor up. The session's already expired. It knows it expired, but it's not telling you until you've done all your editing. You hit save and you go, session expired. Don't like that. Yeah. So we'll discuss how the issues with that paper. But first we'll do the Foldit paper and then we'll come back. Did you guys try Foldit?
Yes.
Did you try iWire?
Yeah.
Yeah. So what did you think of the two as games? We're good. How many games are they?
I played through all the intro levels of Foldit.
Mm-hmm.
And thought it was not very fun. It was interesting, I suppose, but it wasn't very fun.
Yeah.
And when I actually got to the real puzzles, I was overwhelmed.
The complexity
Yeah.
just go.
Yeah.
Yeah, and
And all the intro levels are just do this, do this, do this, and you follow the directions and you get the correct answer. But
Yeah.
there's no exploration during the actual intro levels.
yeah, and
You
I
don't know how that makes you help science.
no, it doesn't feel like I'm helping science, me. I can do science. Yeah, no, I certainly found that for me, Foldit, once I got to the real puzzles, felt very kind of, you know, I'm just poking this thing and wiggling it about a bit. And I'm watching the score a lot to see, okay, up, up. I felt like I was doing sort of the hill climbing search, right? I'm doing sort of genetic algorithm where I've got my location. I check some locations around me to see which has got a higher score, and I go to there, and then I check some locations. I'm just kind of randomly walking around the environment looking for a higher score. And I think, you know, computer can probably do that better than I can. Because I'm pretty slow at doing that kind of thing. So I didn't feel that my human pattern matching powers were being really used well by...
But that's what they sell, isn't it? The description.
That's what they're saying they're using, is they're using humans' ability to do pattern matching as the power. I just didn't...
And 3D visualization.
Yeah, I just didn't really feel it. Did any of you feel like you were empowered and doing science? Or just kind of, you know, pushing stuff around in a random place? Because that's how I felt. Maybe I'm just not science
I
yet.
still wonder if it's mainly about the scar if you do it right. Then why don't they just use an algorithm who tries it all? It might be even better than what humans do.
There is a bunch of contrarian stuff on against Foldit, saying, well, you know, if you use the CPU time on the user's computers and utilize all of that time that the user was sitting there wasting time trying it themselves, you would have actually got more done, right?
Much.
Much more done, because the processor sitting there, like running the graphic card, displaying the graphics, and sitting there waiting for the human to move the mouse. That's a lot of energy being used to facilitate a human doing an action. Whereas if you put all of that power into actually trying everything, then you would actually try far more options and got further.
No.
So
What I was missing was the computer aiding me more. So when I do my action, it kind of does more to see that my action is magnified. Because some things are tedious, you have to, like, if you want to reorganize it, you have to kind of manually reorganize it. But if I just reorganize one thing, the rest would sort of do intelligent thing, right?
Yeah.
Then you can explore more quicker. And I was lacking the support of the computer to be doing the tedious things, which I had to do myself. Yeah.
which is where iWire is trying to does it in a slightly different way. So who tried out iWire? So yeah, okay. So what do you think of iWire?
Easier to play.
It's a little bit better, yeah.
It was more understandable, I
Yeah.
felt. So I mean, I've got iWire on here. iWire. No, I'll go to the iWire. So we can bring out iWire. I do have a. Okay. Oh, it lost the O. Okay. No, there's a sign up. Maybe I can log in. Actually. What? Okay. Okay. What? Okay. I'm sure I've got WebGL. Hit a snag. Rats. Okay. Okay. So iWire, yeah, it does try and do more for you. So I'm currently working on this cell. So I'm part of the community developing this cell. And we can start playing, and I'll get some cube of the cell there, and it's so that's where that that computer assistance of trying to help me find where that branch goes to, and yeah, it does feel a bit like guesswork. So I'm trying to guess that that's included, but. I reckon this whole thing here is all part of it. Which, given that I knew that it was going to get to the other side anyway, probably include this bit here. And so yeah, but this is just kind of it's like paint the numbers kind of. It's something I could probably give. Well, if I gave it to my kids, they would probably just color in the whole thing. Right? My daughter uses she uses the painting game. She makes it go completely painted black, everything black, and then asks you to guess what it is. It's completely black screen, and then you guess randomly, and she'll click somewhere and highlight some bit of it and say, "What is it now?" And so she uses a kind of a real game instead of a painting game. But so yeah, I mean, this is a much simpler game to play in the sense that it's kind of more obvious what's going on, and you can see the computer helping you more. I think that simply. Of course, if I submit this, I'll get a score. And the score here is kind of one of those community scores where you are scoring depending on if other people kind of agree with you according to what you think is part of the cell and not. And you're supposed to get all the tiny bits of it right and make sure that. But it is. There is a feeling here that this kind of cell image is the stuff you see in science, right? And so I was talking to Annie, who is the leader of this program now, and they're trying to develop a new version of iWire, which is more space rockets and aliens and blasters and action adventure game rather than puzzle game. Right, and I'm not sure. Right, this feels like you're doing science, right? And the whole points thing is just a little bit of reinforcement for doing science. It's not. I feel like you're doing science here, right? A little bit, at least. And in fact, I do know. I personally know scientists who do this kind of thing, right? I went to a presentation at Otago. And I felt sorry for the guy because he was doing a neuroscience PhD, and he spent 2.5 years counting the dendrite spines on axons, right? So what he's doing is getting these, and he's looking for the wee knobs to say the number of synapses that were sitting on the ends of one of these axons, right? And just sitting there with a golf clicker, counting them on slides like this. Where it's not all computerized where you can go like that to go to the next slide. It's, an actual photograph that you have to scan and look over. Right? 2 years doing that. And I was thinking, I can actually write a computer program that would kind of do about 95% of that job and probably be more accurate over time than him. I could probably write that in about a month. Yeah. You spent 2 years of your life doing something good. Yeah. So, but I know that that feels like science. So yes, I'll submit my bit of the cube, and I scored another 100 points. Woo!
But they know the solution to this. So how are you helping science?
No, they don't.
No.
Right. So what they do is they present this to me and to 10 other people, and if 8 of us agree, that's the correct solution.
How do you get that to check my work, and then they help you?
Mm-hmm.
It's a button, check my work, and then it shows which part you haven't colored. So
that's in the tutorial sections. Right? So as you
in tutorials, they know
Yeah.
exactly what.
and what you're doing is you're building up trust by playing those tutorials. And then when you play these things, I'm a low trust. I'm not a very highly trusted game player,
Yeah.
right? So they give me confirmation tasks, right? So I get a score based on how well I kind of associate with the real one. As an advanced player, you're getting more and more into you're the first person to ever look at this cube, and you and so some of the things you're doing are completely novel and they have no idea whether you're doing it right or not. Right? They still give you a score for how consistent they think you are, right? Because if you try and do a spine off here and it's obviously wrong, then I can take points away. All right? So the way in which you give points is the amount you include without including something that's obviously wrong.
So right now you're like an apprentice. So
Yes.
some of the master's been before of you, but you don't know. So you are trying to
Yeah. And so
show that you are good enough to
Yeah.
be.
And once I start to become trusted, they move me up and up in the queue of who gets to see the puzzle. And by the time, if you're playing this late, some of these people play, and he was saying about 60 hours a week doing this. Right? And they have often they'll have a real job at 40 hours a week, and then they'll just be all of their free time sitting there doing this because it's what they love doing. They're crazy. But they're very good, some of them, right? And in fact, their best players are generally better than the trained scientists at doing this particular task, right? They are better at detecting the flow through the slices than real scientists. So, and they've even found some of them are actually like there are some grad students and stuff who will be doing their PhDs in neuroscience and do iWire for kicks or something, right? So yeah, so week you and I don't play regularly, so I probably don't earn enough points to be on the table. But it's still not a huge community when in the past week there have only been 485 people who have scored any points at all. Right? So even in the last month, you're looking at, wow. Somehow these people log in, started the puzzle, and then quit, obviously. Didn't even get to the point where they submitted a really crappy thing. So 1,200 people in the last month have participated in this site. That's not a huge community. Right? So in fact, 4 people out of that 1,200, that's not a bad sample size if you considered Norway, and that would mean you'd be like asking several hundred Norwegians. Yeah, I'm not yet, but so we'll go and have a look at Foldit first, and you can discuss the paper, and then we'll come back and discuss the combination paper from Kai. Okay. So are you with us, Marcus? Please. Yeah. Okay. So long as
He's obviously nodding somewhere out there.
He's nodding in the universe, right? Okay. So I'll bring it. Do you want me to bring it up here, or do you want to plug it? Oh, you're not really plugging it, are you? Okay. So I will go to and I didn't. Oh, there it is. Okay. So present the paper.
So I'm going to present the paper, The Challenge of Designing Scientific Discovery Games, which focuses on the development of the game Foldit, which is a game for scientific discovery about figuring out how a given protein will form. Foldit focuses on at least to use human problem-solving ability to solve computationally difficult scientific problems. It turns difficult scientific problems into puzzles and provides a game-like mechanic to allow normal people to help solve these problems. This is a difficult thing that influences all facets of the game's design, and the game must be accessible to beginners with no experience in the field, and they must still remain true to the science to some level. The game can also not be made with a specific solution to problems in mind. This is general for all scientific discovery games, usually, because that's the player's job to figure out the solution to the problems. The game needs to allow the players to reach a potentially correct answer without the designer knowing the actual correct answer. In order to understand specifically what's happening in the game, you might need to understand what a protein is. Proteins are the primary chemical for almost all cellular processes, and it's basically the stuff in the body that allows it to do what it does. Proteins are responsible for a lot of the vital functions in the body, like replicating DNA, breaking down food, and transporting molecules, and so on. Proteins are made from a sequence of amino acids. It's the sequence that dictates the protein function. Amino acids are just small molecules that are made up of quite simple atoms like carbon and oxygen and so on. To make a protein, the amino acids are joined in long chains, where each amino acid has a small group of atoms that's called a side chain, sticking off the main chain, that's called the backbone. There are 20 different kinds of amino acids, and they can be placed in this chain in different ways. That's what the amino acids differ from each other based on what atoms are in their side chains. But it isn't just a long chain. The chain folds in on itself to create a three-dimensional object, and that's what allows the protein to execute its actual function. It always folds the same way every time, or it should at least. This is called the native structure, and it's the most stable shape of the protein, rather the shape with the least amount of free energy. And predicting this folding is based on the amino acid sequence is very important to biochemists, because so much of the protein's function can be understood once the structure is known, and that is very hard to do computationally, normally at least. So making this into a game was seems to be quite a challenging task. They took an iterative approach to the game development because of the complexity of the project, and they would have no idea. There was no way they would do everything correct in the first pass through. So based on the feedback of both scientists and players, they iterate on the game on each update. There are three groups that are quite important to this approach: the scientific experts, whose problems the game is meant to solve, the players, and the game designers themselves. The development team must then incorporate the feedback from all players to make sure the game is understandable and fun, and from the experts to make sure that the results produced will be useful to them. They use a normal client-server architecture, where the user installs the client, which then communicates with the server. Scientists pose problems to the server in the form of protein structures, where the players try to find the native structure. These puzzles are then active on the server for about a week, and during this time, the players' solutions are sent to the server, where they're ranked against other solutions to create kind of a competition. Players can then also form groups to work together and on the same solutions. When a puzzle is closed, the data is then sent to the scientists to analyze it. An important aspect of this game, according to them, was making it approachable by regular people. This is important in scientific discovery games in general, I think. Making it very important that the game is not ugly or sterile. It should be, it's quite colorful looking, the game. It's quite brown, fun looking graphics with effects and stuff. The visuals must then also reflect and display the rules of the protein folding in a way that's understandable by regular people, and at the same time hide the protein's real complexity in some way, so the players can follow down. Distilling the protein folding into simple concepts was done usually via graphical stuff like clashes and voids, which are red, and hydrogen bonding, which is blue, or to show the blue is good and red is bad. But I think the paper here shows these 4 concepts: clashes, voids, hydrogen bonding, and hydrophobic side chains. And it's not quite that simple. There's a lot more concepts introduced in the game that that makes it much more complex than it's presented here, I think. When it comes to hiding the complexity of the real proteins, many unimportant details are removed from the actual graphic. That doesn't really impact the folding in any way. Side chains are also hidden generally, if not they're involved in a clash. And only the biggest clashes are actually shown to the player, because when there actually are clashes, there's a lot. But there's no need to overwhelm the players with all this information. The interaction of the game must also achieve several purposes of scientific discovery games in general. They must respect the constraints of science. They must also be allowed to explore all possible solutions in a manner that helps the players so actually being able to solve the problems. It must also be intuitive, and some fun must be involved. To ensure that the players' interaction respects the constraints of real protein folding, we developed a number of tools for players to use based on Rosetta, which actually the entire game is built on top of the Rosetta molecular modeling suite, which is software that contains algorithms for computational modeling and analysis of protein structures. By using Rosetta, they could ensure that the results are somewhat close to the real plausible protein structures that were listed. In order to confirm that the interactions available folded were sufficient to explore the protein structures enough that you could actually make a real discovery from this game, there were several test puzzles in which the native structure was visible as a guide, allowing the players to try to follow this guide as closely as possible. And the fact that the players was actually able to create these real proteins based on this shows that the tools provided is enough to reach the native structure of an actual unknown protein as well. In order to make the interactions more intuitive and fun, they made it so you could directly interact with the protein with the mouse. Originally, you couldn't do that. You could just manipulate sliders and buttons and stuff. I don't really know how that would work. But they quickly changed it to using the mouse. They seem to say that that makes it quite easy and fun. I found the mouse controls quite clunky. I can't really make it do what I wanted most of the time without a lot of fiddling. The scoring of the game, since the puzzles are inherent, the answers to the puzzles are inherently unknown, there cannot be a point where the correct answer is actually reached. So the goal must then be that to just direct the players to reach a possible solution. In order to do this, Foldit organized the game in the form of a competition between the players. So the goal is to get the higher score than all the other players. The score is based on the Rosetta technology, which gives higher scores the lower the energy of the protein, which means that it's closer to its native state. It's also this game also tries to teach new players how all that stuff I talked about works, like the visualization, the interactivity, and scoring. This is done via a series of introductory levels, teaching all the gameplay concepts, which is quite a lot actually. In Foldit, we teach they teach the gameplay concepts through where each level introduces the player to a new problem that relates to a concept in the game. these concepts are introduced through and using hints, as they call it. I just thought it was a guide that showed exactly what you need to do. The levels are designed in such a way that using newly introduced concepts is the way to reach the low score. Levels were then refined through play testing and data collection from the players. If they saw a lot of people just stopping in a specific level, they tried to tweak it so less people stop there. There's certainly, personally, I feel just way too many of them, and they did not help me not feel overwhelmed when I reached the actual puzzles. To evaluate the game, to evaluate if they actually could use this method to gain actual solutions to protein folding, they entered a bunch of the solutions into CASP8, which is a competition in protein structure prediction method, which I'd say is an interesting way to test it out, while possibly not conclusive scientific results. Certainly, I think it shows that it's not completely off the mark. I've seen most of the entries actually got a relatively high score. There's not really too much else to say about it now, I think. Anything, questions or thoughts?
So in this evaluation, when you look at the scoring, right, folded rankings, what were your thoughts on these?
They're not too bad. There's a big spread, of course, but mostly on the upper range, I'd say. But I don't know what that proves.
One thing it could prove, if you talk about improving the average, one thing could be it could filter out bad submissions. Right? So one way of improving your average is to get rid of the weakest performers. Right? So in New Zealand, we had a research assessment exercise for academics. Right? We call it the performance-based research funding model in New Zealand. And one of the universities, Auckland, gamed the system by putting all of their teaching fellows who weren't producing research on 9-month contracts and keeping their pay the same as it was on 4-year contracts. So basically they would pay them as if they were working a full year, but say they're only working 9 months, and they would qualify as part of the average for the researchers. Okay? So the teaching staff would be employed, basically, if it was in Norway, you'd be employed from August to May. You wouldn't be employed in June and July. Well, actually, they'd need to, June, July, August. You'd start September, work to mid-May. You do 9-month contract, and therefore not be full-time staff and not be counted in the average. So goal it could be, the program could actually just be being used as, really bad solutions never get past its filter, and so never get submitted. And so the average performance of its submissions are higher than normal labs who don't have the same filter for bad solutions. What do you guys think of that? Because there is a small discussion on using actual computers and comparing it to the automated searching. What did you think of that evaluation?
You mean using the Rosetta at home and stuff like that?
Yeah.
I don't know. I don't really know too much about that before. But it's using idle computers to using distributed computing, right?
Mm-hmm.
I don't see why we can't have both. think it's
Oh, yeah. Yeah. So scoring, there is a Rosetta at home. I'm sure I can find where it.
you don't really say anything about it. Just say this is.
Yeah, yeah. And it's included in there some of their performance. They, yeah, team rankings and then total performance, total rankings, total rankings. So yeah, I know the Rosetta at home. I know that if players don't feel like we're using something unique about the human brain, that we're just kind of searching a play space, then is it sensible to consume resources providing that information to humans to do it worse than the computer?
Didn't actually humans solve illness in monkeys that was like cancer using folded?
Yes, there is but so you will find there was one of the retroviruses was in monkey was using folded protein. That was the protein challenge.
Did humans solve it, or was it?
It was solved by folded plates,
Yeah.
right?
Yeah.
But the question is, if they had spent the same amount of resource on Rosetta at home, would they have also solved it? Right?
Yeah.
So it's actually that one's a hard one to know. Right? It may be that when you train long enough on the Rosetta program, you actually get better than the computer at searching space. Now, have you guys talked about search spaces in other courses? Like a problem space and how you search through it? Okay, so if you think of Foldit and iWire and all of these kind of scientific discovery things, you can think of them as having a search space. And so we can bring up search space. So we have a solution and we give it a score, right? And if we go to images, you'll see I've got a bunch of those. Yeah, these are various search spaces, like that, for example. So the idea is that you've got an environment and every position is some combination of parameters, right? So for the Foldit one, it's a combination of how the main backbone is folded and how the individual protein arms are folded, right? So each of those is a parameter that you can change, and it changes a value somewhere, right? And in this case, score. So what you're doing is this location, you look at the locations around you, and each of those have a score value. So if you flatten this out into 2D, you could think of this as having a surface. As I move in this direction, I change my value a little bit. And I change a bit more, and I change my value a bit more, I change a bit more, I change. So you think of it as a landscape, and what you're trying to do is you're trying to find the tallest hill in that landscape, right? You're trying to find that globally maximal solution, the best possible fold. Now, there are, just like a normal landscape, potentially little hills, which are the best local solution. And when in Foldit, you get it to do, like you'll see here, when you do these wiggling, right? So I'll stop that. So it's got 8226. And if I take some small thing and bend it, try and get it to bend, I went down 900 points, right? So in my landscape, I'd made one shift in this direction and it went down the hill, right? And as I make other changes, I may lose some more points. Let's see. These are generally quite small changes. Oh, okay. Grab some small, rotate around. I lost another 9 points. And I lost 7,000 points. I thought that was quite a small thing to change, but apparently that created 7,000 points of loss. And yeah, so when I wiggle the side chains, what I'm doing is I'm making lots of the small adjustments around the point I'm in and looking and all the area around me to see if any of those points are higher in the score than I am. Right? So those are the small wiggles. When I do the wiggle the backbone, you would think that it would probably be, again, it's searching around using the backbone to wiggle, searching around the space. Now, we have this kind of concept of a well-behaved space and a badly behaved space. A search space is well-behaved means that small changes in parameters lead to small changes in score. Right? This is nice, it's nice food, and so I can easily go from this point, I can look around and go, oh, the slope goes in that direction. If I keep going in that direction, I'll get higher and higher scores, right? Because it's nice and smooth. A bad landscape to search in, like that small change I made there, losing 7,000 points, I basically fell off a cliff by making that small change. It went bang down to 0. Right? Now, a landscape that is all just spikes and zeros, any change you make radically changes your score all the time. You can't search in that space. Right? Where's the tallest mountain in a space where this meter goes up to there 1,000 meters, and I move 1 meter that way, and it comes back down 1,000 meters? How do I hunt for the highest point in the landscape? Right?
You need to climb them all.
You need to climb them all, and that's exhaustive search, right? And it's just no fun. So when you're looking at landscapes and looking for searching, you have to think, like, what is the space? What is the representational space? So you see that, like, this one is relatively well behaved. There seems to be this valley here, and this is a pretty flat area. Like this shows an example of some. Oh, right. So these would be local maxima and one global maxima. Right? And the idea is if you started in one of these points, you would search and wiggle up to here, and you stop saying, "Oh, this is the best gold I've got." And each time you did a change, you would find that your performance would decrease, and so you wouldn't make any change. And what it's saying is that humans are better at moving from this space to this space by doing some weird combinations. Right? That humans somehow pattern match and search the space there. Genetic algorithms are a form of parameter search. Right? And what we're saying is that, the way that our genes work is that the performance is some sort of, ability to have children, right, and breed. And so that's the measurement. And then your genes do a bunch of small random variations to move around, make me slightly different to my brothers and sisters and my parents, that I'm searching this, what is the best human evolutionary kind of space. Right? Now, they suggest that sexual selection, right, where you cross, like you take half of my genes and mix them with a whole different person and go kind of slam to see what that does, is kind of jumping somewhere a long way in evolutionary space. Right? If we were all just clones, we'd all be searching around the same area. Right? But because we do sexual selection, we genetically jump further and so mix up our search space for what's the optimal solution. There are some species which are clones. Right? There is a couple of, is it one of the lizardfish or lizards or something? There is one species which are all females, and they're all identical clones of each other, and they have asexual breeding, and they're all identical. Their DNA, all the same.
It's the frogs, because I remember that from Jurassic Park.
Okay, yeah. So there is a species, maybe a species of frog, but yeah, they're all genetically identical. There are no sexual selection going on.
Which means that gender is of no interest.
Yeah, there is no gender, right? It doesn't matter whether you call them female or male, because they aren't really. They're just one of them, and they just keep breeding.
But going back to the genetic algorithms,
yep.
One of the reasons why it works is that you randomly choose various points in that space. So you have, rather than have one point and try to optimize from one point, you optimize from many different points. And now if you combine two of these points, then you get to some of the points that aren't initially in that selection. So that's a bit what it works.
Yeah. So you
And
can.
you also have mutation to jump you off one thing.
Well, mutations are usually used to do little changes, and the crossovers are usually used for big changes.
Yeah, but
So-
the thing is that without mutation, the big crossover can not always happen. So you need to mix it up.
So you have
mutations here usually on 5%.
Yes. Very well.
you don't want to have too much mutation.
No, that's
Yeah,
direct word.
mutations are just noise, some random noise in the process.
And we also and there are various selection types you can do. Like unlike in real world, where we as individuals are going to die, right? Even if one of you people might be the perfect human specimen, right? I'm fairly sure I'm not, but even if you were the perfect human specimen, you're going to die at some point, right? Now, what we can do in computers is we can keep the best solution around permanently and just keep it into the next population and keep it into the next population, and we can keep it and just make mutations from it, but still keep it around. We don't have to mutate it and destroy it. We can keep that one and compare its mutations to it and compare its children to it and just keep it around as a potential solution.
Always be in the gene pool.
Yes, the Methuselah selection process. Whereas, in real life, you have this kind of turnover. So even if you got to a really good solution, all those individuals might die, and you lose that solution. Right? So this folded program is competing directly against that kind of parameter search. Right? So there's a brute force approach where you just search everything. Or there's a genetic algorithm approach where you kind of try to use mutations and crossovers. So yeah, whether it's better, and what's your overall evaluation?
I don't really. It seems at least that this has a small user base that is really dedicated. And they probably get some results, but I don't know if it's better than doing it computationally if you have a big distributed network.
So yes, efficiency becomes a question, and this is if you ever do kind of analysis, knowing both effect and efficiency is important. So for example, I mean, I'm painting. I've got paint on my hands a little bit. I'm painting a bed with my son at the moment. It would be far more effective for me to just buy a blue bed for him than to take his sister's bed and paint it blue. But it's an activity we do together, so it's fun time with Dad where he gets to splash paint on his bed, and then when we're finished, he gets to say he painted his bed, right? So the achievement isn't about efficiency; it's about the human process of achieving that, right? And so I saw some same discussion around recycling, right? Actually, if you look at the energy efficiency of the kind of recycling that most of us do, it's not actually sensible. And look at the recycling over here where they truck it to Sweden to recycle it, right? So the carbon footprint of recycling is often higher in Norway than just disposing of the stuff, right? But there is a kind of long-term strategy related to slowly turning people into the idea of recycling and reuse, that once we get past the threshold, then will be beneficial, right? And so this engages people with science. So maybe the science they generate isn't efficient and effective, but perhaps the psychological engagement with science.
Should be said that an effect I got from playing this game was that I started reading up on proteins and stuff like that because it interested me.
You understand more about
I wanted
proteins
to
now.
know what I was looking at. So now I know more than I did before I played the game.
Yeah.
So even if the scientists didn't learn anything from me, I learned.
You learn something from them, which is really nice. So I think we should actually have a break, a 10-minute break. See, I keep forgetting to give you guys a break. But we'll have a break and then we'll come back and we'll talk the ACM paper. Are you guys probably too young to know about thalidomide? I don't know how to spell it. Thalidomide. Related to protein folding? So there's R thalidomide and S thalidomide. No, to do with this body. It's a drug, and in the lab they tested R thalidomide, and I think R thalidomide was all good and had no problems, and it's a painkiller. But unfortunately, when they give it to pregnant women and they manufactured it industrially, they got R and S. They got two different folds. The two different folds that you see here, one of them, fine, no problem. The other, massive birth defects, no arms, extra arms, limbs missing, like you're just horrendous birth defects. So you get these kids who like, yeah, their arms just never develop, their hands never develop, their wrong numbers of fingers. These were the thalidomide babies. So yeah, babies with kind of, yeah, massive deformation because their mother was given thalidomide as a painkiller, right? And had been tested safe, but they tested only the one they produced in the lab, which was only one of the folds because of the particular process. When you mash all of those drugs together in an industrial process, you've got both folds, one fold deadly, the other fold fine. Okay? So, you know, fold it. Like this folding proteins is right, really has had a massive impact on humans. So, okay, go have a 10-minute break. I'll grab a coffee and come back and we'll talk about an ACM Chi paper, or a Chi paper, which is
Nå er han på idrettsgallaen som vant årets handicap mannlig utøver. Han er jo sånn. Driver med seiling. Har hvite armer. Bare to sånne.
Det kan jo være noe annet grunn, vil jeg tro.
Ja, men
det er ute av produksjon for så lenge siden, så...
Ja, han er jo voksen da. Han skal voksen, han gutten.
Ja, jeg vet ikke.
Men han har jo veldig stort bein. Og alle armer. Bare noen sånne...
Ja da, jeg tror det er flere ting som trygger det. Because these babies were born quite a long time ago.
Yeah.
How long? 70s?
Yeah, I think it was 60s or 70s. Yeah, it was
I thought it was
before our times.
yeah, 60s, I think. And spelling it is hard.
Yeah. It's 54 when they patented it.
Yeah.
So it might be, yeah, might
When
be.
did they put it on the market? First.
It was for market at 57. Well, they probably took it off the market straight after the initial.
Yeah, but you should take some time for them to realize that it's connected. 59, late 59.
Okay, 61. So 4 years. So in 57 it was introduced, 61 it was taken out of the market. Yeah, we were just checking with Rune. So it was discovered like in 56 and 57 went on the market.
Yes.
And in 61 was taken out of the market, but it's one of the success stories of drug marketing because within 3 years it was sold in massive amounts and marketed in 46 countries.
Yes. It went from, oh, we found a painkiller to everyone use this one.
And they marketed it heavily in United Kingdom, Australia, and New Zealand
Yeah.
as a morning sickness remedy for mothers. Yeah.
And the problem is, you know,
With no side effects whatsoever, the safest.
yeah, they marketed heavily in New Zealand and the UK. And the thing is that actually thalidomide is a very good painkiller. You just have to make sure you're not pregnant. Right? If you're not pregnant, it's fine. Right? So if they just said pregnant mothers should never take it, no women should take it, right? Just in case you might be pregnant, right? But everyone else, it's perfectly fine. Right? It doesn't matter which fold you get. It doesn't destroy you once you're fully formed. It only, while you're an embryo, the thalidomide drug changes the way the chemicals help develop the body.
So would that, like, for instance, after the embryo, like when there's an actual baby, would that then be affected or like?
No, it's only during the early stages. So once you've got your fingers developed, it doesn't retract them, right? It doesn't stop them growing. It just damages those chemical signals when your fingers are developing and when your arms are developing. Once you've got them, it doesn't make them go away. So thalidomide would actually be perfectly fine for the rest of us, just not pregnant women. And yeah, so actually, because basically you cannot get thalidomide. Well, you can get thalidomide, but you don't. Nobody really prescribes thalidomide because it's got such a bad name now.
Mm-hmm.
That people think it's going to turn them from this into someone who has no arms and legs, right? Because they don't. Yeah, there's that kind of psychological mismatch, and it has such a terrible reputation because these are called thalidomide babies, right? Because that's how they're referred to. So, though, did you have much of that in Norway?
Some, but they gave them a different name, I believe.
Yeah, it was marketed under different names. Yeah,
Right.
but I'm sure it was in Norway too.
Yeah. I'm trying to remember what the original name was. I can't.
But yeah, no. So for me, the whole the folded thing is this links very closely to that what happens when you get the wrong fold. So yeah. Yeah.
But it would be interesting if to write, for instance, a genetic or evolutionary algorithm comparing to the folded users to see who was the most useful one in regards to the results.
Oh, I believe if
They do that.
One.
I think
There is already I think there was. I thought I saw a paper on that particular genetic algorithm, protein folding versus folding. I think there was already an article in Scholar on that. I do it in Scholar page. I thought I saw a comparison article on that particular question. Protein folding. Oh no, that's question mark. Stupid. Not knowing my keyboard.
yeah, there is also another game which we discussed last year. Was that Philo game for DNA mapping?
Mm-hmm.
Yeah, I quite like that one.
Yep. Okay.
There was another one listed like further forward into this. If you see number, that one. I'm not sure if that's what the word.
No, that was a bit early. I was doing something more recent than that.
Then you should buy food. Food?
Food? There's...
Yeah.
Oh no, it's not
It's a
food inside.
Just carbs.
But
That's
it's cheese.
what my grandmother
I
calls
thought
food.
everyone was cheese.
Fats and carbs.
Damn. Cheese.
But is brown cheese or normal
Yes.
cheese? Brown
I
cheese.
wanted brown cheese.
Brown cheese is everything except cheese. Right? Brown
No,
cheese
it's
is
cheese.
no. Brown
No.
cheese is the
It's cheese
inverse.
magically made even
No,
more
when
delicious.
you remove the cheese from the milk, what's left is what you make the brown cheese out of.
Yes. So brown cheese is
Basically
explicitly
sugar,
everything that
basically sugar
isn't.
liquid.
Yeah, it's
You're welcome.
condensed milk. Don't you use
There's not a
condensed milk
condensed
or
right
Viking milk?
No, that's entirely different.
That's different, yes.
Yeah,
If you-
Because that still have the
condensed milk is what milk.
You can still make cheese out of it.
okay, yeah, but if you cook it long enough, you will get caramel, which is
Yeah,
almost a brown.
No.
Yes, you do if you do.
You do get caramel, yes, and you can buy caramelized condensed milk already, right?
Oh yes.
But yeah, and you
Very
can,
popular with some.
and you can buy it in tubes, so you can drink the
Oh.
condensed milk directly.
Sorry, no.
Actually, I found the coffee and milk, where what they do is they get basically instant coffee and blend it with condensed milk. So the idea is you put 2 teaspoons of this into a cup and just add hot water, and you get a milk sugar coffee. So every two
All the one.
every 2 teaspoons of this is a full coffee, and you can drink that straight. That's pretty intense. And you can do that during exams, which gives you like massive amount of caffeine during your exam. But brown cheese is what you get when you make cheese and you have whey. The rest of the world generally feeds that to like pigs or
protein
use it to
shakes.
fertilize things.
Yeah, protein shakes.
Protein shakes is whey.
Yeah.
Everything is whey.
Yep, it's whey product because it's a byproduct of making
It's
cheese.
really good.
It's everything that isn't cheese
I don't
turned into
care.
something they call cheese.
It's called cheese.
Yes, it's Yep.
It tastes like cheese, at least a little bit.
it would be like calling Marmite beer.
Yeah, no.
Because Marmite, you guys have tried
Tasty.
Marmite?
Oh.
No,
It's a
I'll
British,
have-
Tasty. You need to eat
Well,
the
the
cheese.
proper one's the New Zealand version.
Oh.
But
Can you get Marmite
Obviously.
in Norway?
no,
I
We get
think
a
it would taste good with Brunost.
That'd be odd.
Nice birthday.
I haven't tried that. I've got a bunch of Marmite. I'll bring in Marmite one day. Marmite is everything that is the
Bring the
leftover
Brunost to-
from making beer, right? So what you find is people like in harsh environments. Well, in
Like in New Zealand.
New Zealand and Norway, people will make food out of stuff that everyone else thinks is waste. Right? So everyone else just pours the whey down the drain, and everyone else takes the dead yeast out of the bottom of beer, and uses it to fertilize the garden because it's like
You can buy it in Germany too, just not with the name Marmite. You go to these expensive, very biological, ecological shops, and there you can buy it.
Yeah, and basically you take the yeast from making beer, and what we do in New Zealand is like you do with whey. With the whey, they boil it until it kind of goes brown and sticky, and then call it cheese.
And it's sweet.
And it's sweet. And what we do with beer is you take the dead yeast, you boil it until it goes black and sticky
And not sweet.
And salty.
and salty and very, very yeasty.
And what is that?
That's called Marmite, and we put it on toast and we eat it.
Oh yeah, I think I've seen that on iHerb. I order a lot of things on iHerb, and
Right.
is that like
A yeast extract.
Yeah. I take it actually as a supplement. Yeah,
Right,
to make my hair grow.
right. We eat it with toast.
What's the difference between the
Vegemite
For
and
normal
Marmite.
people, it's not good.
It's
It's the acquired taste.
The Marmite
from
has-
down under?
I love it.
Yeah, there's a red Marmite.
Yeah.
Marmite
Yeah,
has more
okay.
caramel in it and actually has more flavorings, whereas Vegemite tends to be a bit sort of, yeah, I find it.
It's milder. Vegemite
Yeah.
is a bit milder.
Yeah. So.
And I heard someone feed it to their dogs to,
Whoop.
yeah, some,
Possibly.
yeah.
There's
Five second
also,
rule.
you can also get powdered
Yes,
yeast,
we don't have it on
Yeah.
video.
which is also another, like, you take it
That
until
part
you
of
dry
USA.
it, until it turns into a powder, and then you sprinkle it on toast, and
Yeah.
that's
And popcorn.
and on popcorn, yeah,
Yeah.
it's weird. Trust me, when you have no other food, you will find something and eat it.
I happen to like Marmite.
Yeah, that's good.
Because it's
I like it as well.
I like
And the
it.
kids in New Zealand in the kindergarten, they have it. They
That's
don't
the
toast.
brown
Yeah,
cheese
well,
here as well.
And if you have problems with something to eat, you should go up in the mountains sometime and have a sheep head and have the eyeball
No.
and the brain and whatever else.
And the pig feet, pickled pig feet.
Yeah, right.
Yeah,
Yeah,
see,
well,
yeah,
my grandfather
Norwegians will
favorite,
I mean, you really have problems, you go to China.
yeah, you don't even want to know what it is anymore. No, it's
If it has 4 legs, it's not a table, it will be eaten.
Yep.
And if it's an egg that's gone bad, they still eat it.
Yeah.
Yep.
No.
Well, I heard strange stories about Norway and the fish, the like
Lutefisk?
yeah, lutefisk
No,
and rafisk and stuff, and how like weird kind of it's
Oh,
rotten,
no.
but we eat
I
it.
want to know more about it.
Okay, so the second paper, that's actually where we get the second paper we're looking at is an ACM, right? And you know, normally you would expect ACM, the Chi article. Chi is a big conference. Chi has a fairly high rejection rate. So I think they accept around 25% to 20% of submissions.
Is that much? I thought it was even lower.
Maybe it
Well, I think it's lower.
Might be down around
Was
13, 12. So, you know, they're right in the kind of, you know, they'll get 2,000 submissions.
So 2014 acceptance rate was 23%.
23%. Okay. So 23%. So it's a 23%. So you think for every one that's accepted, there's another 3 to 4 that have been rejected. Right. So this is one of the
It's
accepted
kind of
ones.
interesting because they say historically it was between 14 and 16.
Yeah.
2014 was exceptionally high, 23%.
Yes, so last year was an exceptionally high acceptance rate. So they
You
got
were right. All of us are right.
We were both right. see how we. we'll find a solution. We were all right. That's lovely.
We're the regional.
Yep, I was right. You were right. We're fine. So this is. So I'm presenting this paper. So this paper is a initial start of a research program, right? So these people that had a question, they kind of at the very initial stages of their question, they wrote a
Just if you go to the top, you can see it's a work in progress.
Yep. So work in progress paper. So this is not a we've finished something. This is what we are planning to do. Sometimes these are now coming out as we're demarking this space so that this is our research plan. So when people look and they're wanting to do it, they'll treat it as something that we're doing, so they'll talk to us about it and stuff, right? So you're trying to mark out some space to saying this is my area of research. So works in progress. It's also partly because one of the challenges both for conferences and journals is that with computer science moving sort of games and mobile and development changing so quickly, journals and conferences become archival rather than communicative, right? So rather than communicating current research activity, they are a place you put your research to register that you've done it and archive what you did, right? So nobody goes to the journals to read the current state of the art. They go to the journals to read the history of an area, right? Because you want to know what's currently being done. You go and read the blogs of the researchers who are currently doing the research, or you go to conferences and you don't listen to what they talk about. You go and talk to them and see what they're currently doing, right? Because the stuff you present at the conference is often about a year old. And in a year, quite a lot can change in computer science. Well, in in mobile game development, so these interactions. So what conferences do is say, well, instead of having a 6 month, you submit, 6 months later we'll tell you whether or not you can you create a conference, and then 3 months later you go to the conference. So 9 months from when you submit something to when you actually turn up to conference, which means you were doing that a year ago. They've started adding these work in progress tracks and the current research track. And so what you do is, depending on the conference, one of the things they can start doing is saying, hey, you guys have been publishing in Kai for a while and you publish interesting stuff. So how about we kind of have an open, what your current research or work in progress thing. Just submit us kind of an idea of what you're doing and then come and actually present it with the stuff you just discovered last night and come to the conference and talk about it. Right? And in fact, there is a movement called an unconference. You guys heard of the unconference movement? Mm-hmm. Okay. So the unconference movement is they've decided that this kind of, submit a paper, get it peer reviewed, get accepted, turn up, present what you had, isn't useful. Right? That delay is too much. So the unconference is the idea that you have no predefined papers that have been written, and what you do is you get people to apply to come to the unconference with a CV saying, hey, I'm an interesting person doing interesting research. And you just put all the people who are interested in the topic, who are doing research in the topic, in a room together and say, come up with new cool shit. Go for it. Right? And so it's not a conference of presenting what you've done in the past. It's a conference for planning what you want to do and potential collaborations where you describe what you've been doing to each other and you think about what you want to do from there. Right? So they don't have this kind of conference feel where you have all these competing sessions. You just get everybody interested in an idea, that's the room for that idea. Everybody interested in an idea, that's the room for that idea. Right? It's far more useful than a conference, but the game of academic publishing means that we don't get points for that particular behavior, and so academics don't do it because that's not how we score points. Right? And have we described the academic publishing points system in Norway? There's level 1 and level 2. We get 3 points for a level 2 and 1 point for a level 1 publication, and 0.7 for there's another for a level 1 that's not that you're part of a series, that you're only part of the level 1, you get 0.7, and then you share those points with all of the collaborators you have in Norway, and so we have this point scoring system. And the average academic in Norway, I think they're looking at the NTNU merger, was scoring 1.1 point or 1.2 points a year. And we each get individual points, and so I've got my points ranking against everyone else in the department. So I think I scored 4.5, 5. No, I scored 5.5 points last year. I think. So which I got a lot of points last year, partly because Costas was publishing a lot as well, right? And I'm half of his publications because we work together. And I think our top scorer got 13 points. Right? NTNU is averaging 1.2 points. I think they don't like Sotranala because it's averaging 0.7 points or something, right? So we're playing a game, and conferences are one of the ways you go to earn points. Right? This is the game that academics play. So let's give you some of the background on this work in progress. So this paper, what they decided to do was say, hey, we're interested in citizen science. They then shortened it to CS, which of course confuses me because I'm always CS computer science. Citizen science. And what they did is they went and they trawled the forums on Foldit and iWire and asked for volunteers to take part in a survey of why they play Foldit and iWire. And they got 4 volunteers from each, which doesn't seem a lot of work. And they then, so they introduce the area, what citizen science is, gamification of games with purpose. So they describe the area, and then they look at what motivates people to be engaged in citizen science, and whether the game motivates people to come on board or whether it motivates them to stay, basically. And they did exploratory interviews on the people who happened to volunteer for this kind of scientific evaluation. Right? And so yeah, so they talk about the method, yes, an opportunity sample of 8 participants. An opportunity sample. What do you think that means? What would you think that would mean? Have you seen the phrase before? Look it up. Opportunity sample. Oh, except. No. Opportunity sample. Sampling methods. Yeah, it's recognized. And find opportunity sample. Many psychologists have a bias sample because they used an opportunity sample that comprises university students as their participants. So, you know, it's research as one of the causes of bias is using an opportunity sample. So, yeah, I'm glad they said it was an opportunity sample, but you know, they're almost explicitly saying, hey, yeah, we're biased.
That means like they went into a lecture and asked someone playing Fortnite, okay, come with me, I need to do a survey.
That would be one opportunity sample. The other is you go on the forum and say, hey, anybody want to do anyone want to participate in an interview? And when someone says yes, you go, great, done.
Not to forget they were paid to participate. So they could have even written, hey, you get £15 for participating. Who wants to do it?
Who wants free $15 for talking about Foldit? So there is a lot of discussion around whether the opportunity samples are a good idea, but you know they're honest that it was just an opportunity. I believe they just happened to get 4 males and 4 females. So as you said, that mean age of 47, a relatively high standard deviation. So they obviously had some young people and some potentially older, right? So some in their 60s potentially, though with so few numbers, standard deviation doesn't seem to mean very much. 47, I also find that very old for asking them if it was the game that attracted them to the science. Because I'm kind of the front edge of gamers who have always been gamers. So I'm at 40. I can't really remember a time when I wasn't playing computer games. Right? But I'm kind of the first wave of that. Right? So Rune can probably remember a time as a child when he wasn't playing computer games.
I didn't have a computer.
Well, he didn't even have a computer.
I didn't have a computer until I went to military service at 19 years old. That's the first time I took a computer.
Yeah. So I had my own computer at 10. And I was playing arcade games from about 7, and I don't really have much memory before I was 7. Right? I don't know why I don't remember much before I was 7, but I just don't remember much before I was 7. So I don't really, I can't access memories where I didn't have computers and I wasn't playing. When I was 4, we moved to Dunedin, and my father was using the computer at university. So he was using a computer when I was 4, and I remember, and I don't remember that, but you know, it's part of the experience. So if your average age is 47, you're more talking, and this was 2013. So, and they would have asked in 2012. So this is 3 years ago. So now those people, the average age 50. At that average, a bunch of those people had come to games later in life, not from all their experience. So yeah, so there are challenges. So that interview, semi-structured interview. You guys know what a semi-structured interview is? Kind of. Yeah.
So semi-unstructured.
yeah, semi-structured and semi-unstructured. structured, unstructured. So yeah, basically they then just asked them, each individual lasted up to an hour, took place over Skype and was audio recorded so they could go back through and transcribe the discussion. So basically you get paid £15 to chat about your thing over Skype with the researcher. They then did a thematic analysis and transcribing and coding.
I also like that thematic analysis. I mean, that's not very accurate methodology either. Let's look at something here, let's look at something there. Okay,
let's just map out everything that they did. Yeah, so basically what they did is they just kind of, they used it.
Answers.
Yeah, they kind of chatted with them for a while. They had some set questions, right, that they'll ask, and then they chatted them for a while and see what they'd talk about when they were talking about the game. And then you go through and you transcribe the audio recording. And when you're doing coding, you're looking for either particular words or particular phrases, and you code those in particular ways, right? So this is often done when when people are trying to analyze text, try and turn it into kind of mash of words into something you can analyze, right? They encode it. And so you look at coding negative words, right? So the number of times you're negative about something. And so one of the things they're trying to do with Gamergate and tweets related to Gamergate to see if they were sexist or abusive or those sort of things. So what you do is you look for the Gamergate hashtag and then negative or positive comments, and you try and code them in that way. Of course, automatic codings have problems, and so you try and get humans to read it and encode. And you could use a Mechanical Turk to do that if you were going to pay people. But so the idea is that you then encode these, and what they did is they kind of encoded the chunks of the conversations to try and do thematic analysis, where, you know, what did people talk about? So they broke this into initial motivations and grabbed examples of what they considered an indication of initial motivation. So my family's quite geeky. My mum had already installed one of the first collaborative sciences to compute proteins. So it's a long time that I've been aware of these things, right? So so the question of, how did you find out about Foldit? This would be a perfectly reasonable answer, right? And so here you're starting to talk about, you know, you try and analyze this and you code that as mentioning family, right? So family or friends as a motivator, right? So you could categorize, bin that into family and friends. And then the theme of continued analysis, so the question is kind of, why do you keep playing? Why are you still playing? Three is, so forum chat motivations. So a question on community, why, like, what do you think of because both Foldit and iWire have a community aspect. iWire is very much on the sidebar there immediately all the time. You see the chat come up, you see people chatting, they'll say hello to you. When Annie presents her stuff at conferences, she'll log on to iWire and she'll say hi to people who are playing the game at the time during her presentation, right? And they'll say hi from wherever they happen to be in the world. So that community is a large aspect of iWire, certainly. So yes, on the group chat we talk about whatever, pictures of kittens, families, right? So to some of these people, that community aspect is more like playing bridge, right? So the actual activity they're doing is irrelevant to the discussions they have just with other human beings that share some interest. My sister, for example, is part of a scientific knitters group, right? Who are research scientists who like to knit. And so they do things like, you know, DNA scarves, where they do double helix scarf, knitting double helixes as scarves and things. And they'll knit proteins, like, you know, she does research in a lab and she likes to knit. So, and that's a relatively small community, but they share a bunch of interests and they talk about whatever. And you know, when they talk about their kids, that shared interest in genetics and interest in knitting is kind of a commonality they can go back to and start the conversation around and just talk about life. Right? So some of this community is formed around that. And so they then, you know, they all participants fully debriefed and received £15 gift voucher. Probably Amazon gift voucher, probably. It's the easiest one to do. So, yeah, so they do these analysis and they talk about, yes, the desired improvement. Again, with so few, it's hard to see these as commonalities. They're just, you know, our focus group, we asked them some stuff and they gave us some feedback. And the design implications. So they have some desires for improvement. So I'd like to have more contact, perhaps like the weekly progress gallery or similar. So that's for who also, to see similarities and difference between the way I see a connectome and the way someone else pictures the same one, right? So these often the people engaged are looking for ways of improving their engagement. There is some really difficult challenges with asking within a community that is existing how to improve that community. It's one of the challenges we have with how do you, if you want to encourage more women to do computer science, do you ask women who are already doing computer science how to encourage them to do computer science? Because they're already doing it. So they're not the ones that are not doing it, so they're not the ones who know why they're not doing it, right? So it's a...
They might still.
They might have some ideas.
You know, they might have friends.
They might have friends. But perhaps you should ask the friends why they're not doing it, right? Because people in the community are already in the community. And so if you want to know what's wrong with the community, asking people who have left. Right? This is one of the things we do with we're looking at students who fail courses. Like to work out how you improve a course, you don't ask the A students, how do we improve this course? Because they enjoyed it and it worked for them. If you ask people who are failing or who have left, why did you leave? Right? So asking people in the community how to improve it might not actually make it better for the general population. And having done a relatively, well, I don't know, they spent 8 hours. So they spent one day interviewing people, and then they spent, say, 3 or 4 days writing it up. So this is kind of 5 days worth of work. Yeah. Got them a point. So
4 people. 4 people.
4 people
worked on this. So.
Yeah. yes, you can criticize that. Well, okay.
One worked on it, and 3 were looking at what he was doing, but he credited
and they took credit.
So that really works.
And so what you
unfortunately, that's the approach many places exists.
Yeah. So most likely, Iona did the whole thing, right? Wrote it up. Charles and Cassandra probably helped with some of the writing. And Anne may be the head of the lab, right? And said, yes, that's acceptable, you should attend it. And had no actual contribution of writing the paper at all. Okay? So when you say 4, you probably mean 1. So that's just how actually...
One who discussed ideas with the other guys.
Yeah, one who did most of the work and the other 2 contributed in some way, right? But they all share the points.
So the one thing that I don't buy into here is the game part, because most of the discussion we're talking about the team play. Do they mean team or team play? They don't discuss much of the game in teams as much as they enjoy being part of a team and working with others, and the social aspect is important, obviously, but is is the social game that's important. I mean, the feedback. There's just one of the comments they have cited that goes to gaming at all. Everything else you can say, oh, any social interaction would
It's a community.
Yeah.
Any community of activity. Yeah. And I think, okay, for me, the reason why that you get this particular output is that sample of opportunity. You went on the forums, right? Which means you're already targeting people who are actively communicating on the forums, right? And are actively communicating in the chat, and so are there not necessarily focused on playing the game and getting the game played, but on the community. So in a community where you go and ask people who are focused on the community aspect of an activity, what do you like about that activity? They're going to tell you that it's the community aspect, right? Because if you went to a chess tournament or a bridge event, right, you might find that if you engage people in conversation, the people who are most likely to engage you in conversation are the people who are there not to focus on playing bridge, but to focus on talking to people. The guy who's there because he's a professional bridge player and is training won't listen to you and won't engage, right? And if you say, hey, can you spend an hour with me not playing bridge, but talking to me about why you play bridge? He'll go, no, I'm busy. And just keep focusing on getting better at the game. Whereas the people who turn up to the bridge event to chat to Mildred because they like seeing her every week, will you chat about what you do? Oh, yeah, I'd love to talk. So what you find out is that if you ask those people why they like playing bridge, they all like playing bridge for talking about playing bridge. Yeah? So a sample of people who like talking about the game they play happen to like it because they like talking to people. What you need to do is actually go to people who don't want to talk about why they play the game and ask them why they play the game. Right?
Force them to talk.
Force them to talk about why do you play this game. Because there is nothing here that says, you know, so the conclusions for me, and we're getting 11 o'clock, the conclusions of what it means for the design of the discussion of future work and design implications. The using teams makes sense. Meaningful game mechanics, they're very much focused on these. These people are there because of the science, right? And you guys have all said, you know, it feels like you are kind of, you know, relatively doing science in a sense, right? It's very visually scientific. They're saying this is a good thing. But there's that risk of saying, well, you know, these two games they're comparing are games that look like you're doing science. People who are playing them and actively engage them are probably happy that they look that way. So asking them the design implications are saying, you know, keep making it the way they like it, because those are the people who like it like that.
Yeah, well, if you like to keep the player base, then you can do that.
Yes, if you want to keep the same 1,200 people that are playing iWire as the people playing iWire,
you should probably do that way.
You should probably keep designing it in the same way. Right? So for me, the design implications from this one are only valid for people who play the game who like to talk about playing the game rather than necessarily actually play the game, and who are already engaged and actively involved in playing this particular style of game. And both games are relatively similar, right? There's not kind of a completely weird game for science.
The game elements aren't that significant, I feel.
No, it's almost more they're just a way of measuring and feedback. And the last thing, I mean, it doesn't really address the whole exploitation of people, right? Is because when we talk about serious games for health, games for education, the player benefits, right? So the first two we've been talking about, we're actually looking at helping the player get better at something. This one is the first of the player gets no benefit at all from the serious game. The scientist gets benefit. This isn't about helping you as a player. This is about me using your time to achieve something I want to achieve.
Make you feel good about it.
And try and make you feel good about me using you as a slave. Right? So this starts to fall into that exploitation-ware issue. of why gamification and all serious games are bullshit. Which moves us back to the first paper. So yeah, I'm not sure that this is a very strong. I don't think this is a very good paper. Right? It's published, but I think the massive holes. It's very biased. I think its conclusions are very weak. I think the conclusions aren't critical of the sampling method and don't say, okay, so if you only want to attract the people who are already in these environments, then you do these kind of things. So I think there's an issue around exploitation-ware. I think there's an issue around how do you go beyond the communities that are already doing this. And there's a big philosophical discussion around how obvious it is that you are doing science. The same happens to games education. How obvious should it be that you're doing a learning game versus playing? Right? These two are both very sciencey, they look like science. Educational games that look like education, the kids know that they're learning, where does that line fall? Right? And it is a very active debate in the games education community on how much should it look like education versus how much should it just look like a game and be fun and should be kind of, secretly we're teaching you without teaching you. And what is the context and how is that presented? Okay, so for Thursday, unfortunately, Gurad hit some server snags and has been not able to be updated. So what are we wanting to do on Thursday?
I'm working on it as we speak.
He is working on it as we speak. As I am saying to you at the moment, there is code occurring in the corner. Thursday, so you've done your thing. If we look at proposed topics, I will decide one right now and put up the update. Okay, so Nicholas, you did yours job. Who can go on Thursday? Nobody can go on Thursday. What? So we'll make games dieting next week with Sonia and
Wednesday?
Hmm?
On Wednesday?
Next
No,
week,
Tuesday.
Tuesday. Yeah, Tuesday next week. Yeah. Wednesday.
Tuesday.
We'll have to change the date.
Yeah, it's Tuesday today. Yeah.
It is Tuesday
Sorry.
today.
I'm confused.
Oh, it's locked. We locked it. So it would have told me if I checked. So you guys are going to do, and it's a week from today, so it's the 17th.
And when will you publish the papers?
I'll do that today and tomorrow.
Okay.
So I'll publish those two for next Tuesday. So we've got Sebastian wants to come up and give the propaganda games. So he will probably be here on Thursday. I will talk with, I'll ring Sebastian and check to see if he can do this Thursday, because he normally comes up on the Thursday. Otherwise, we will have to pick another topic. I might talk about game taxonomies on Thursday. Okay, sounds reasonable. I'll talk game taxonomies. Okay, so we'll make this, so game taxonomies, which is the 12th of 02, and student is Simon. And we'll talk, and the first paper, which is the gamification and serious games for personalized health paper, which I wrote, so I will review my paper. Should I review my
That's
paper?
going to be nice.
That's a form of bias. I could get Marius to review my paper.
But on the other hand, you probably know best what is the content of the paper.
Yeah, you have the insider's you know.
I think so,
backstory.
and I can be critical of stuff
If you
like that.
have questions not answered in the paper,
You can be
ask
very
me.
critical. Try and I honestly I like criticism. I
So you can give out some bad grades after the course.
no. I consider critique as a sign of intelligence. So if you're critical of the paper and say, well, this bit is shit, and you should have done this, and that's obviously stupid, then that's great, right? I'm more than happy with that.
Simon is probably the only teacher, and so, yeah, maybe Marius too, is probably the only teacher where you can critique their academic work and actually get a better grade.
Jeez, the more you criticize us, the more impressed we are.
I'm fine with criticism.
You haven't seen, well, maybe, well, I don't know. You've had me before in other courses, but I don't know if you really actually criticized. You came back, so I don't know what that means.
That's a good sign. Or maybe there wasn't much choice.
Yeah. Okay. So, and also if you think about these papers, I want you to think about games at that deeper level. Start thinking about is games for science exploitation game, right? Who benefits from games for serious games, and games for education, games for health, games for science, games for propaganda, games for politics, games for persuasion, games for training. Training is one of the ones I think is really interesting because, games for education and games for health, obviously I as a player benefit. A game for training which makes me better at my job. Who benefits from that? Is it me as an employee that I'm now better at my job, and so maybe I can move up and get more money, or I can do it faster and be more efficient? Or is it my company who are paying me to do my job, and making me better at my job means that they get more out of me for the same amount of money?
But the problem is whether or not you're working on a team, because if you're the only one, then you want to end it faster if the team is slower than you per se. So you'll be faster with your task, but you still want to be faster.
It's always good to be better than you were.
You feel better if you are better at what you do.
You can also feel better if you are more confident and more capable. You feel better about what you do. So there is that, as you say, Tanya, both, right? Both benefit from games for training. But games for science, you benefited by learning some stuff. But that's because you're a master's student and you that's what you do, right? You always learn stuff is what you're supposed to do. But how much of these kind of games for science, gamers as work, are beneficial to a third party that isn't the player? Right?
The monkeys? The monkeys?
The monkeys?
Yeah.
The monkeys, the monkey virus discovery. Yeah. So if you're doing science for a good cause, then maybe that's okay. But it starts to be that discussion on who benefits from a serious game, right? And at what point are you exploiting your players?
There's also Die Hard 4 where they actually lured the hackers into creating a program that took down the whole state. So
yeah, there are a bunch of you can do weird things, and there's who benefits from different activities. I think is an interesting kind of discussion around why you make a serious game, right? So taking down hackers, or taking down a state, or the whole.
Because you have a hack this side, which is a serious game in the sense that you're training to become a better hacker. But then there's the ethical side. If you're training to become a black hatter, then there's the
So if you're training to
because you get points and achievements, and you actually have sort of like Foldit, where you have these tasks that are unsolved, which is actually here's this problem, we don't have a solution. Find the best way to hack this without getting caught.
Yeah.
So
training the people to be better hackers. That's
but it's fun. It's like
So I think that we've got some serious sort of things to think about when you talk about serious games, right? And so you guys are going to be on Friday. We are going to be doing some deciding on projects and some idea generation. So I'm going to try you out with some of my animal model stuff on Friday. I think I'll talk to Stein about doing that.
Trying to tell us to come on Friday, even if you're not on the course.
All right, you're not doing that course, are you?
No.
The integrated project.
No.
It will be
I'm not doing
broadcasted
project.
on the channel, so you can.
Do you want to come and watch?
You can join in on.
You can spectate.
Depends if it's still interesting.
Well, you can become an animal. That's partially interesting.
I know what animal I am. I just love cats way too much to be not a cat.
Right, so you're going to be a cat.
Yeah, obviously.
Right.
They're fluffy and furry and soft.
But we've got
They
rabbits.
can purr.
We have bunnies and puppy dogs.
Bunnies are strange creatures, and dogs are, well, dogs.
Right, they're not cats. Right, okay. Okay.